Welcome to qnawire.
Okay, we need to determine what exactly are what of these substituents is an ortho-para director. So let's look at OH. Now, the way I like to think about this is that if oxygen, to determine if oxygen is an ortho-para director, remember that's ortho, meta, para. Oh, I'm drawing my double bonds here. You can think of the oxygen as being partially negative, and then you just alternate bonds, partial positive, partial negative, partial positive, partial negative, partial positive, partial negative. And whichever carbons around the ring are partially negative is where it's going to be directing. So to me, it looks like it's ortho, not meta, and it is para directing. So the OH is ortho, meta, para. And then we can consider these other examples and why they aren't ortho, meta, para directors based on their structure and this partial positive charge thing. So the next one we have is some sort of amide. There's an R group here. So is this partially negative or partially positive? We have to consider basically the resonance form of this. So it would go like, if that created a double bond and this double bond kicked up onto here, what would it look like? This would be N minus, and this would be plus. So that's the resonance form, which means this would be delta negative, delta plus, delta, draw my double bonds here, delta plus, delta negative, delta plus. So the positions that are delta negative are with the meta, para, just meta. So it's not ortho, meta, para, or ortho, para directing. The final ones then are, it looks like a carboxylic acid. And basically this is the same thing where we consider the resonance form. Looking like positive here, which, as you may notice, is the same situation we had with the amide, where there's a positive charge on an atom directly bound to the ring, which means the connection point, the ipso position, will be partially negative. Ortho will be positive, meta will be negative, and para will be positive, making this also meta directing. And finally, we have nitrile, which I'll just show. The relevant resonance structure for a nitrile is once again going to create a positive charge on the ipso position. This is the resonance structure we need to consider. And just to hammer it home, I'll show what this would mean for the benzene ring is that the ipso position, or the position the carbon is attached to, would be partially negative. Ortho would be partially positive. Meta would be partially negative. Para would be partially positive. Meta would be partially negative. And ortho, again, would be partially positive, which makes this, OMP, makes it meta directing. Meta directing.